Okay, pre-calculus. We're doing some notes for P-7. And what I'm writing on right now is available to you. It's in the pre-calculus documents folder, which should have been linked on the checklist. Okay, so you can print it out, or you can just handwrite what I'm doing if you can't print anything out. So the title of this section for P7 is Solving Inequalities. Algebraically and graphically. So just like we were solving some equations using graphs, we're going to learn how to solve inequalities using graphs. Okay, and also a little bit algebraically. So the box here, solving absolute value inequalities. This is something that you learned how to do in Algebra 2. If we have the absolute value of u is less than a. You may remember that if you think of that in terms of a number line, what we're really saying is what numbers u have a distance from 0, because that's what absolute value means, distance from 0, that is less than a. So we have all of these numbers over here have a distance from 0 that is less than a, but a itself is not. So I'm going to put an open parentheses here. But on the other side of 0, we can go all the way to negative a. And so you get this range here, which if we write that in integral or interval notation, you get this, from negative a to a, open parentheses, because we're not doing brackets because it's not equal to. If it was less than or equal to, we would use brackets. So this can be rewritten as a compound inequality like this. Negative a is less than u, which is less than a. And so that's what you do to solve it. You rewrite it as one of these, and then you solve this. If it's greater than, we have the absolute value of u is greater than a, then if we think about it in terms of that number line, we're saying u has to be a number that has a distance from 0 that is greater than a. So in that case, it needs to be far away from 0. It can't be close to 0, and by close we mean have a distance of a, or less than, or from 0 to a is pretty much not allowed. And again, a is not being included here, so we're going to put parentheses. But then we can also go on to the negative side and do the same thing. Now to write that as a interval, or in interval notation, we would say one part would be negative infinity to negative a. That's this part right here. And the other part is from a to infinity. Everything's parentheses. The infinities always have parentheses. And again, we're not doing equal to. If we were doing equal to, we'd put brackets here and here. This is an or compound inequality, so you would write it that way if you were using the inequality notation. Okay? So let's just do a little practice. So there's 2 pages to this. This page is going to be on the right hand side. Let me just look up the page number real quick. Okay, it looks to be page 23. So this is going to be page 23 right here. So the 23 will be in the corner. The example we're going to do on page 22. So that's actually the second page here. So this is going to be page 22. So we'll do this first one. Solve algebraically. Absolute value of x minus 4 is less than 8. So the first thing we need to do is identify if this is a less than or a greater than. Actually, that's a lot. Before you can even do that, you have to make sure that the absolute value is completely isolated. So if I gave you an example like this, okay, it says greater than, right? But the absolute value is not isolated because we are multiplying it by a -3. Don't distribute into absolute values. You're not allowed to do that. So instead, I'm going to divide both sides by -3. Cancel, cancel. Now, when you divide by a negative in an inequality, you have to remember that that changes. So we get the absolute value of x minus 4 is less than 8. So now I have that problem. So just make sure that if you're given something that the absolute value is not isolated, you need to isolate it first. Alrighty. So x minus 4 is less than, the absolute value of x minus 4 is less than 8. If we go back and look at the notes, less than is this one right here. We want to make it an and inequality like that. So we're going to rewrite it like that. Okay, so we're going to have less thans. The stuff in the absolute value is what's going to go in the middle. And then the 8 is going to go here, and then I'm going to put a -8 here. -8, x minus 4, 8. Okay, this is a compound inequality. We're just going to add 4 to all sides. We get -4 is less than x, which is less than 12, and we're done. We can graph that. 0, 12, -4. This is going to be open and connect. Okay? In any interval notation, this would be -4, 12. Alright, so now I'm going to teach you how to solve these graphically. Okay, so we're going to write down some steps. So, to solve the absolute value of u is less than v, or the absolute value of u is greater than v graphically. Okay, so it depends on if it's less than or greater than. So here are your steps. First, you're going to graph each side of that, just like we did when we were solving equations graphically. We're going to graph y equals the absolute value of u, right? That would be this side, this side. So you're going to go into Desmos or a graphing calculator, and you're going to do y equals the absolute value of u. Then you're going to graph v. Specifically, you're going to graph y equals v. That's just going to be a horizontal line. Let's see if I can get this. Okay, so if I graph y equals the absolute value of u, you get this. This is the absolute value of u graph. It's just a V shape that you may remember from Algebra 2. Okay, then the other one, y equals v, that's just a constant, so you're going to get a horizontal line. You know what, I don't know why I'm using v. They used a, and I'm messing it all up. I don't know where the v came from. I'm just going to change that. My apologies. Okay, y equals a. Not that it really matters, it's just an arbitrary constant, right? A. Okay, so there's y equals a. So y equals the absolute value of u. Okay, now if we were solving an equation, we would just be looking at the intersection points like we talked about last week. But we're not solving an equation, we're solving an inequality. Okay? So in the case of solving the less than, what you're looking at is what values of x, right? This would have an x in there somewhere because that's what we're solving for, x. Would y equals the absolute value of u be lower or less than y equals a? Okay, so we're looking at when is this one below this one. So let's identify that. Okay, so that occurs here. Just this portion right here is when it is less than. So the values of x are basically right here. If we think of this as your number line. And that is what we got before, isn't it? That is basically that compound inequality of and. Okay, so when is this true? It's true between negative a and a. Or in inequality style, it's between negative a and a. Okay, same thing, different ways of writing it here. So what values of the absolute value of u graph are going to be greater than or higher than the y equals absolute value of a? And essentially you have these two pieces here. Okay, those two portions are when it's above or higher than. Okay, so if we bring that down, we're looking at this. Wow, that highlighter's big. That's okay. So that piece right there would be negative infinity to negative a. That piece right there would be a, because remember this is open, to positive infinity. Okay, now I'm going to teach you a new symbol. It looks kind of like a U, but you can see how it's not like this. It's just like that. It's called the union symbol. And the union symbol is kind of like the symbol for the word or. There's another symbol that's upside down version, that's the intersection symbol, which is another way of saying and. These are set notation symbols. So think of this like a set, and I'm saying the union of these two, or the word or. Okay? Alright, so I want you to go to Desmos.com or get a graphing calculator, because I'm going to have you practice with me on this part. Okay? Okay, so we're doing example 2. Solve graphically. The absolute value of 3x minus 2 is greater than or equal to 5. Okay, so what we're going to type into Desmos is basically we're going to take this half, we're going to do a function, and you're going to do an equal sign, not an inequality in any way. And then you're going to take the 5, and you're going to do y equals 5. Okay, so we're not putting any inequalities, we're not typing this whole thing in. Alright, so going to Desmos.com, launching calculator, I'm going to close this, I'm going to make this into projector mode to make it better. Okay, y equals the absolute value. So when you type in the little bar, it makes 2 bars. It's handy. 3x minus 2. Okay, that's the absolute value of 3x minus 2 as a graph. You get this V shape. Then we're going to do y equals 5. Okay, so that's a little low. That's why you couldn't see it. Okay, so go ahead and do that. Pause it if you need to. All right, so we have some intersection points, and now those are not the answers, but they're important to the answers. Okay, so I want to write on this, so I'm going to take a quick screenshot of it and play with it. There we go. Okay. So the problem had us wanted to know when it was greater than or equal to. So if we look back at our problem, we're looking at when this one is greater than or equal to the 5. Okay, so let's look at that picture again. So we want to know when the red one is greater than the blue one, and that happens here and here, and this is going to keep going on and on and on, right? And over here as well. So you have to keep that in mind. So kind of you want to drop it down to the x-axis where it starts. It starts at -1, and it's going to keep going forever in this direction. And then on the other side, oh, it did not like that today. Okay, and then over here we're going to drop this one down. This one's at 2 1/3, and then we're going to go this way. And I'm going to put brackets here, because these are equal to, because our problem had an equal to in it. Alright, so how we answer this is I would write this part right here as -infinity to -1 bracket union with this part, which is going to also have a bracket, and it's 2 1/3. I would not write 2.333 because that's rounding. If you have 3's repeating, it's 1/3. So I'm going to say 2 1/3, comma, positive infinity. That's your solution. Now if I switch this around and I said when is it less than, then we'd be looking at this portion. And then it would be this from here to here. Okay? Alright, we're going to do one more. I want to show you how to solve a quadratic graphically, because this way of solving an inequality doesn't just have to work for absolute values. It definitely is a good case to show how to do that, but this one you probably have no other way of doing it. We can't solve this one really very well algebraically, and so we're going to talk about how do you solve this graphically. Okay, so the first thing you do want to do in this case is, I mean, you could do it the other way where you separate it and you graph 2x squared plus 3x on one side and graph 20 on the other side, but in quadratics we know a lot about parabolas, so it's actually going to be nice to solve it by setting it equal to 0 first. So I'm going to subtract 20 from both sides. So we have 2x squared plus 3x minus 20 is less than or equal to 0. Okay, now let's just pretend that this is an equal sign for now. Okay, let's just solve this equation as if this was an equal sign. It's not, but we can pretend. Okay, so we would do some factoring, right? Multiply 2 times -20, that's -40. Put the 3 here. And then two numbers that multiply to make -40 and add to make 3 are 8 and -5. So if you use my method of factoring this way, you write x plus 8, x minus 5, although that's not your answer. You then have to divide the 8 and the 5 by the 2. You reduce. In this case, you get x plus 4. In this case, it doesn't reduce, so you put the 2 up here. Okay, this is correct factorization, so we're solving. You get -4 and 5 halves. Now, we understand that those are the x-intercepts of the parabola that would be y equals 2x squared plus 3x minus 20, right? These are the x-intercepts. And that would be the solution if it was an equal sign. So this picture over here, if you haven't already figured out, this is the graph of y equals 2x squared plus 3x minus 20. This is an example from your book, by the way. I took this picture from your book. And when you see these things down here in the book, you see negative 10 to 10 and negative 25 to 25. What they're telling you is the scale that the x-axis is going. So this is negative 10. This is 10. And what the y-axis is doing. So this is the y. So this is negative 25 down here. So these are not going by ones. These are going by, looks like 5s, and then this is positive 25 up here. Okay, so that's what those numbers mean. And that's in interval notation, right? Okay, so we can see that this point right here is the negative 4 x-intercept, and 5 halves is just 2.5. And you can see that that's right there. So there's 5 halves. Okay, so remember that this is an inequality. What we're really doing is we're trying to find the place where this parabola is less than or equal to 0. So 0, I mean, there's a couple ways you could think of this. You could think of 0 as a line, right? 0, the line y equals 0, that has another name. It's called the x-axis. Okay? That's this thing right here. So you can think of it as, when is that parabola below the x-axis? Another way you can think of it is, we're asking, when is the parabola negative? Because less than or equal to means less than or equal to 0 means negative. So when is it negative? Basically all of this, right? This is the part that we're looking at. So when is it, so that's the part we're looking at. So when is it negative? So we're asking at what value of x is it negative? Well, just this part, these x's is the graph negative. So when we write that, and it said also there was an equal to, so this is going to be bracket negative 4, comma, 5 halves, bracket. It's this region here. Oops, I went a little too far there. Okay. I can connect 2 dots. Yay! Alright, so that's P-7 for you. Put these notes in your notebook, do the homework, email me if you have any questions.